Bizarre and eerie signals coming from far distant regions of the cosmos are nothing new to astronomers. But sometimes a new signal is detected that surprises and baffles the astronomers tasked with finding its source. Occasionally, a signal gives researchers a vast trove of information that allows them to delve deep into their mysteries. Astronomers had just detected a very energetic object emitting a fast radio burst that has spit out an insane number of radio bursts in a very short period of time. This series of signals came from an object named FRB 20201124A, which was first detected using China's super-powered aperture spherical radio telescope. The super-large radio telescope's aperture measures a staggering 500 meters and is built into a natural depression in the landscape of southern China. Fast radio bursts have been the subject of many studies over the past 15 years. The information that was used to find the first FRB came from the year 2001. It wasn't until years later that the information collected was analyzed by researchers and the first FRB was discovered. But the source of these strange signals could not be ascertained from that data, and scientists spent countless hours over the next several years trying to figure out what type of object could cause these types of radio signals. In many of the instances astronomers detected FRBs, the signal only came one time, and there has been no way to reliably predict when a new round of FRBs is going to pass by Earth. But researchers just caught a break as a repeating series of fast radio bursts were detected in our own backyard, just a short distance from us in the Milky Way. Just a couple of years ago, astronomers were able to find evidence for the first time pointing towards at least one source of these mysterious signals: a rapidly spinning neutron star. Neutron stars are special remnants of already dead stars that are formed when the core of a massive star collapses on itself after it has reached the end of its life. A star's core is already incredibly dense when it reaches the end of its life, so it is already the source of a lot of gravitational energy. The gravitational force generated by its mass causes the core to collapse in on itself, smashing its matter together and creating one of the densest objects in the universe, a neutron star. In fact, the gravitational strength of a neutron star forces all of its atoms to smash together, fusing electrons with protons and creating a big ball of pure neutrons. But figuring out what kind of object can cause FRBs is not enough. In order to understand more about these FRBs, scientists will need to find as many of them as possible, especially the rare repeating FRBs. One of the researchers, an astronomer based out of Las Vegas, Nevada, was quoted saying, "It is clear that FRBs are more mysterious than what we had imagined. More multi-wavelength observational campaigns are needed to further unveil the nature of these objects." Luckily for them, this newly detected repeating FRB has given astronomers a huge amount of information they can use to understand more about these mysterious signals. These most recently detected FRBs happened to fall into the category of rare bursts that repeat. And not only did this one repeat a few times, it also went off nearly 2,000 times in just under 2 months. After this event ended, astronomers detected a total of 1,863 bursts. Each one of these signals occurred over the course of a 91-hour observation period set up by the researchers. The plethora of information given from this unique event means that the astronomers studying it had enough information to figure out where these radio signals originated and about their journey to us. All of that evidence is pointing to this set of FRBs originating from a very special type of neutron star called a magnetar, located in a distant dwarf galaxy not too different from the Milky Way, over 3 billion light-years away from Earth. But what are magnetars, and how did the researchers decide that the source of the FRBs was a magnetar? Magnetars are somewhat of a more recent discovery, as they are quite a bit rarer than run-of-the-mill neutron stars, but scientists know that they are some of the most powerful objects in our universe, with some of the most violent environments around. There is no consensus as to how some neutron stars end up becoming magnetars. It could have to do with their environment or the star's makeup before it reached the end of their life. But there is no doubt that their fate is most likely decided by the time the stellar core collapses in on itself. They are known for their rapid spinning, which generates an incredibly strong magnetic field that can extend far further than their physical body into the space around them. Astronomers believe that the extreme magnetic fields of magnetars are unbridled. They can get bent and twisted, causing the magnetic field lines to cross, which can lead to a massive eruption of stored energy. It is still unclear if eruptions like these are the original cause of fast radio bursts, but it is still a distant possibility. If that is true, all of this hyperactivity would explain how the largest sample of repeating fast radio burst data ever detected was able to be recorded by astronomers. And with more samples of these electromagnetic signals, they had more help figuring out where these signals came from and what kind of environment they passed through on their journey to Earth's telescopes. Remember that radio waves are just another form of light, and light has a special property called polarization that refers to its orientation in space as it travels. Because many FRBs only emit signals once and they then travel an insane distance to reach our telescopes on Earth, it can be hard to pull all that much information from them. But with this many samples of polarized light, the astronomers were able to study their polarization many times over to refine their findings. After that was done, they discovered that these radio waves originated in an environment dominated by an extremely powerful magnetic field, which lines up well with the leading theory of its source. The next step will task the researchers with finding a way to confirm what the evidence is suggesting so far. Now that astronomers have narrowed their sights on a possible source for these signals, they can focus on finding more evidence corroborating their theory in addition to understanding more about these fascinating objects. There is a hope that more of these repeating FRBs will be detected over the next few years now that the search can be directed better thanks to this new information. Figuring out how our universe and everything in it functions is an overreaching goal for much of science. Whenever something that has been observed and not understood finally comes fully into the light, we come one step closer to becoming the masters of our own universe. Thanks for watching. If you liked this video, don't forget to hit that like button and leave us a comment down below and let us know what your favorite recent space discovery is. See you next time on Matter.